Okay, so can we start?
Sure, go ahead.
Okay, so thank you all for joining us. What we are going to do in the next hour or so, we're going to discuss about how identity management, identity and access management is done for resources in AWS and Azure. So we're going to talk about how the various mechanisms are in place in both vendors, and through the comparison, we're going to understand better each mechanism, right? So this is, if you have some experience in one of them or even in both, this workshop really helps put things in place and really understand how the basic mechanisms for IAM for both vendors work. Now, the first thing that I want to talk about is why is this really important, right? So this is a huge issue and a huge part of the stack of securing any kind of cloud infrastructure that a lot of practitioners today don't really handle. Okay, so we do have a lot to go over, and we have just 1 hour, so we're going to try to cram as much as we can into it. I'm going to try to leave some time for questions at the end, but if you do have anything that you want to have addressed, feel free to put it in the chat, and perhaps we'll pause for it. But of course, we're going to start by just going into a little bit about why we even got into this practice. So there was a very famous case with one very large financial organization that was breached, and the fallout from the breach was extremely dire because of misconfigured permissions. Right, the fallout could have been very limited to specific resources that the compromised component could have just had access to for its business reasons. But since it had very wide access, and we're going to see how that played out, the fallout was extreme, right? And then we as a company got to the conclusion that the practice of providing permissions and managing access in a least privileged way is extremely important when it comes to the cloud, right? Things got very ephemeral, very dynamic. They change all the time. It's very easy to make mistakes. And even not as a mistake, it's very easy to just give very wide permissions as developers and as people who deploy software and want things to work. And sometimes doing that can really hit you where you don't expect it, right? Things would work great, but access would be very wide. And when a breach would occur, things would go south really fast. And this is why it's important to give this a lot of attention. So what we're going to do is we're going to discuss the two platforms, right? So we have a lot to talk about. These are the concepts that we're going to go into, and even more than that. But what we see here in this diagram is that the basic paradigm for providing access is essentially the same as it is in pretty much any kind of resource in any kind of computing infrastructure, right? So when we talk about providing access, you always have some sort of an identity that gets some sort of permissions to a set of resources, right? This is the essential paradigm of providing access. Now, what this diagram does is it takes the IAM service in AWS and resource-based access in Azure, and basically makes the comparison about where each component falls into that paradigm. And this is basically what we're going to go over today, and we're also going to try to talk a little bit about governance. But one thing before we go, and that is something that a lot of people get wrong and confuses them, is the concept of a role. So whenever you hear a role, be very careful as to what it actually means, because a role in AWS is something very different from a role in Azure. And also, by the way, we're also going to mention this, there are two types of roles in Azure, right? So it gets even a little bit more complex. This is why on the outset, we make this distinction, right? So the first thing that we're going to talk about, and this is basically the foundation to understanding access, is understanding how resources are structured. Now, in AWS, you have what is called an AWS account, right? AWS account would hold your resources, and AWS accounts using a tool in AWS called AWS Organizations can roll up into what are called organizational units, and those eventually roll up into your root. So, and this is basically the structure that in which you would manage your AWS accounts. I should say that it's not something that, when granting permission, is something that is going to be actually very useful. We're going to see that. But in the Azure directory, what is called, the structure is very, very different. It's actually very, very, very structured. So in Azure, what you have as a fundamental group is what is called a resource group. So resources, are grouped in resource groups, and several resource groups actually roll up into a subscription. Now, a few subscriptions can roll up into what is called a management group, and management groups can actually roll up into other management groups, all up until what is called the root management group. Now, there's actually a logic behind that. So resource groups are where you would group resources that are meant to be provisioned together, right? So if you have an application, you take all the resources that are supposed to be driven for that application. So they are provisioned together, they're deprovisioned together, and you would want to manage them together when you manage access to that application, right? Now, they would roll up to a subscription, which is basically the billing unit in Azure, right? So resources which are billed together are placed in the same subscription. So the same, their resource groups would be placed in the same subscription. And the way you manage management groups is by your organizational structure. So the same subscriptions for the same organizational unit within your organization would go into a management group. Now, we're going to understand in a minute why this is very important when we talk about access management. So let's see how it looks in the consoles. So in AWS, this is the AWS Organizations Console. What you do here is you basically either add AWS accounts or invite existing AWS accounts into your organization where you actually manage them. And as we said before, you can manage them in organizational units, and they all roll up eventually into your root. And we're going to see where this becomes very important far along. Now, in Azure, for each of the type of scopes that we mentioned before, the resource group, the subscription, and the management group, we have a blade to manage them. Now, we also have this tree view for seeing where they roll up into one another, right? So here we can see the subscriptions, here we can see the resource groups, and eventually this is the basic takeaway, right? So you have this comparison. Again, it's not one-to-one because their use is not exactly the same, and we're going to see that when we're going to apply the access. But this is basically how things are stack up. Now, the next part that we're going to talk about is we talked a little bit about where the resources are. Now we're going to talk about how permissions are granted. So essentially, in both cases, permissions are granted via documents. So you have a document that lists the permissions that are actually going to be granted to the identity. Now, in AWS, that document is called a policy, right? So it's going to look, this is the console, this is the IAM service. You can look into policies, and this is what a policy would look like. Very simple policy has a statement that makes the combination of actions and resources. So you would list the resources, and using an asterisk as a wildcard, and you would list the actions that are going to be granted access to on that resource. And then what you need to do is you need to take that document, you need to take that policy and attach it to an identity. And that way you give the access, right? It's that simple. And that is why it's very, very dangerous. Because if you just use an asterisk in the wrong place, you grant access to a wide set of resources and possibly to a wide set of actions, right? So how this would work is you would construct a policy. Now, a policy can either be managed. So it's a document that is managed in one place, and you can assign it access to several identities. And it can be managed either by you, so it's a customer managed policy, or it can be managed by AWS. So it's an AWS managed policy. So if it's an AWS managed policy, You don't have control over what kind of actions and what kind of resources are listed there. You just use it and you hope that AWS manage it in a good way. Because, for example, if you have a role, if you have a function, job function that you want to be performed, then you just use it. Now, when it's a customer managed policy, you actually manage the policy itself. So let's see how it looks. This is, for example, a snippet from AWS managed policy called security audit, right? It's policy that you would provide to someone who's going to do a security audit on your environment, right? So AWS manages it. They determine what's in it, and you can see here for example, this is one of the statements. This is the action to be performed on this set of resources. Again, wildcard means everything. And as a managed policy, it has versions. So as they change it, it changes versions, and you can see which one is the default, meaning that it's the one that is currently active from this policy. Now, these are managed policies. AWS also allows you to have what is called an inline policy. So if you go to an identity, you can directly add a policy that is only used for this specific identity, right? It can't be applied somewhere else, right? And it isn't managed separately from the identity. So here you can see all the potential policy, all the policies that are attached to this specific identity, either AWS managed or customer managed or inline managed. Now, the way it works in Azure is similar, but different. So in Azure, instead of a policy, you have what is called a role. Now, and again, this is where it gets confusing, so pay attention. So a role is very similar to a policy in the sense that it's also a document, right? It looks like this, right? So it also lists the actions that you can perform. So for example, here, and there is a differentiation in an Azure role between control plane actions and data plane actions. So control planes such as managerial actions and data plane actions such as accessing data. So for example, in the storage resource, it would be the ability to actually access the data within the storage. And that's the way it looks. The main difference between an Azure role and an AWS policy is that an Azure role does not specify the resources where the actions would actually be applied on. That happens somewhere else, and we're going to see that. So, and another thing, by the way, is that you can exclude certain actions by specifying this part, right? What we saw before, you can specify actions and data actions, but you can also specify actions that you want to exclude. Now, you've got to pay attention that this is not a deny, you just exclude them from the list of actions that you gave before. Now, moving on. So you can also create a custom role, same as you can create a custom policy or a managed policy in AWS. You can choose the permissions. And one final thing is that, as I said, you cannot set the resources where it would actually be applied. But when you create a custom role, you can set what is called the assignable scopes. So you can set where that role would be able to be applied. And we're going to see how it applies in just a minute. But you can limit the places where the scopes where it can actually be applied. So the subscriptions or the resource groups or the resources, etc. This is sort of the takeaway, right? So it's the comparison, the objects that we saw. And the main thing I think that to take away from this is, first of all, you always need to strive to least privilege. So you got to be really careful when you use wildcards. Because one thing that we saw in both cases is that you can use a wildcard and basically give a lot of permissions. This is where a lot of people make mistakes. Now, the second thing is that if you use the vendor managed documents, right, the vendor managed policies or roles, then what these usually do is they give a wide set of permissions. And in AWS, they also do it usually for a wide set of resources. So that is also something that you need to be extremely careful with, because it's very tempting to use the vendor managed policies, but it can also have sort of effect that when you use it, you give it to a much wider than needed set of resources or set of actions. So you got to look out for that. Now, the final component of what we looked at, the diagram, is the identities, right? The identities part. So in AWS, you have basically three types of identities that you need to look at. So basically two. So these are users and roles, what are called principals. And also one more thing that you need to look at is what is called user groups. So user groups it's a very easy concept to understand, and we're going to go over it. So users, as you might expect, are objects or identities meant to be used by human users, though I should say as a note that it's a very discouraged practice to actually give human users access using IAM users, where you want to federate them, and we're going to talk about that again in a second. But you do need to be familiar with the concept of an IAM user, because if you have them in your environment, especially if they have access keys enabled, then they can be something that an attacker can actually would actually love to use if they gain access to those access keys, right? So this is what the console for managing a user would look like. You can manage security credentials, and as with any identity, whether it's a user or a role or a group, you can actually set a set of permissions for them to be able to use. Now, for a group is a very simple thing to understand. It's basically a container for several users. That's it. It's that simple in AWS. And you can give the group a set of permissions, right? So you put users in the group and you give the group permissions, and the users, they get permissions by their membership of the group. Now, probably the most important concept to understand in AWS, in the AWS identity, is the role. So the role is an assumable identity. So it's an identity that is assumable. It can be assumed by other identities and then provide access to resources. So it can either be used, for example, by an AWS service, right? So if I want to provide, let's say, Lambda, which is the serverless function service in AWS, if I want to provide it with access to resources, I would allow Lambda, I would put it in what's called the trust relationship of the role, and it will then be able to access resources within my environment. Now, another way, another set of identities I can give access using a role are external identities, right? So if I want to provide identities from outside of my account to have access to resources within my account, the way I do it is I allow them to assume the role, right? Assuming the role is actually a function on the role as a resource. It's something that we get access to. And then external identities can actually assume the role and then use the permissions that it has set on it, right? So I set a policy on the role, and then external identities can actually use the permissions on that policy. Now, finally, a very, very important usage of a role is using federation. When I want to federate, let's say I have an IDP like Okta, where I actually manage my users. What I do is I set up a role and I configure Okta to be able to assume that role and then provide the resources, the access, the permissions that role has access to the users that it managed. And then if I have users that I manage there, let's say my developers, they can access the AWS resources using their Okta identity. And that is actually the better practice, because the users are centralized and managed in a single place. Now, this is the diagram that we made for understanding, the relationship between the type of resources that we have. And we can see here just how much of a pillar the IAM role is, right? You can use an IAM user, again, though it's not the best practice. And of course, you can use groups, and everything is assigned essentially via policy. But we can see that a lot of things can actually access our environment using a role, right? So in And also one more thing that we see here that we're going to touch on later on is what is called a resource-based policy, which we still have not gotten to yet. But for now, this is the essential structure that we have for the identities. Now, in Azure, things are a tad different. But so first thing, we have users, similar as we have in AWS, with one major distinction that Azure is also an Active Directory, means that it also is used as an identity provider, and that's why it's much more used for managing users. Now, sorry. Now, so of course we have the user as an identity, as a very basic unit for identity. Now we also have groups in Azure, with another distinction that in Azure, a group is much more versatile, because a group does not only hold users, a group can also hold another group, so it can be nested. And a group can also hold what is called a service principal, which we'll touch on in a second, which is an object that basically represents an application, or it can represent other things. But it makes things a lot more versatile, because we don't just, we can use a group for much more than just managing users and providing them with access. So what is a service principal? As we said before, in AWS, we have the concept of a role, which can be assumed, and then the permissions granted to it can be used by other identities. Now, we don't have that in Azure, but what we do have is what is called a service principal, which is used by applications and other resources. So this is how it works. Let's say I have an application, right? And it's registered. So it's basically its home directory is in one place, right? I have an Azure tenant where I hold it. Now, let's say I want to give it access to resources within that tenant. So what I do is I create a service principal for it. Basically, it's created automatically. We're going to see that. And using that object, it can actually access resources. Now, why have two separate objects, one for the application and one for it to use to access resources? And the reason for that is that more often than not, I would want that application to be able to access resources in other tenants. And the way it would work, the other tenant would create a service principal for it that it can actually use and access resources. So it doesn't assume it, it just has access to it, it's linked to it, and then it can use it, right? So the way this would work is I would register an application. This is how it looks. So I create the registration for the application, and now I have an object for it. And I also have, on top of the application object, I have what is called a service principal that it can actually use. Now, another type of identity, which is very important in Azure, is what is called a managed identity. So let's say I have resources that I want to provide them access to, same as I discussed about AWS Lambda that wants to access resources within my environment. I have, let's say I have applications, or I have machines, or I have functions, which is the parallel for Lambda in Azure, and I want them to access to resources. So for that, I would use what is called a managed identity. So a managed identity is basically an object. It can be either a system assigned managed identity, which is a one-to-one identity specifically on the resource. So for example, if I have a web application, a system assigned managed identity for it would be a managed identity created specifically for it. And then I give the managed identity access to resources, and then that web application does. Now, another type of managed identity is what is called a user assigned managed identity. So this is an identity managed separately from the resources that need to use access. And usually I would define it based on a job function that it needs to do. So let's say I have managed identity for processing, or for generating reports, or for analyzing images. And then what I would do is I would provide access to the resource to the managed identity that it wants. And here it's a one-to-many relationship, right? So the way it would work is I would go, and for each type of resource where this is applicable, so for example, for a function, I can go to its identity blade, and then I can create a system assigned identity for it. And then it has system assigned identity. And when it comes to user-assigned identities, I can go and on the other tab, right? See, we had the tab for system assigned. Here we have the tab for user assigned. I can assign it. So for example, here I have another function app. I can assign it with a user assigned managed identity. Now, wrapping all this up, right? We reviewed the types of identities that we have in Azure and the roles, which are actually the documents that list the functions that they can actually do. What I need to do is I need to go to a scope. So a scope is where the permissions will actually be granted. So for example, if I give permissions for a subscription, that means that I would give access to all the resources. So all the resource groups under that subscriptions and all the resources within it to perform the actions listed in a role. So, and I create that in what is called a role assignment. So here we have a subscription. I would add a role assignment to it. And when I add a role assignment to it, I choose a role, right? So in this case, a role called contributor. It's an Azure managed role, what is called a built-in role. So I take the contributor, I give access to this group, right? Yet another test group. And when I do, I create what is called a role assignment. So I created, using this process, I created a role assignment for the group to perform the actions in the contributor role in the scope of the subscription, the org1 subscription 1 scope, right? That is the triage of the role assignment. So I can also go for every scope, for a subscription or a role or a resource group or a resource, I can go to a blade called IAM and then see a list of role assignments. Now, one thing that you can notice here is that for every role assignment, I can see if the scope where it was granted is actually the resource that I'm viewing. So for example, the subscription, or if it was granted to a higher level of a resource and therefore the permission is inherited. So here, for example, on the second row, I can see that the permission is actually inherited. So it was granted to a management group that actually includes the subscription, right? So, and one more thing is that for some identities, I can actually go and see all the role assignments that are granted to that identity. So for example, here for the user, I can go and see all the Azure role assignments and see what it has access to. And this basically completes this type of diagram of understanding the relationships between the identities and the roles and the scope. Now, the next thing that we're going to go over is we're going to go over what is called policy restrictions. So there are mechanisms that we can use both in AWS and in Azure to fine-tune the permissions that we grant. Right? And it's very important to understand these. Now, this is a very famous diagram taken from the AWS documentation that says how AWS actually evaluates whether an identity can actually perform something. Now, what we saw may seem very, very simple, right? We saw that there's an identity and I granted a policy, and that policy also lists resources and actions, and that's that. But the reality is really more complicated because there are a lot of artifacts that go into play when it comes to actually understanding whether an identity would be granted the access to. Now, it's very important to understand them so we can limit what permissions are granted, but also so we don't grant too much. Now, let's look at it very carefully. So the first very important mechanism that we need to understand is what is called a resource-based policy. So the policies that we talked about before are granted from the point of view of the identity, right? I go to the identity and I tell it, look, you can do this and this and this. Now, I can also go to a resource and put permissions on the resource using what is called a resource-based policy. Now, one use for this is, and you can guess it, is if I want to grant access to identities external to my account, I can do this using this this mechanism, because of course I can't do this from the point of view of the identity, because I don't manage the identities, right? They're managed in an external account. So here, for example, I provide access in this document. I list what is called the principal. This is the name for the identity. I list the principal from another account, right? This starts with 463, and I am in account 226, right? So I provide this account with external access to this resource. Now, this mechanism, the mechanism of resource-based policy, is also very good for limiting access, because what I can also do is I can set what we saw before was an allow, right? But what I can also do is I can set a deny. So let's say, for example, I'm on a bucket, and that bucket actually holds very sensitive information. And what I want to do is I want to limit access to a specific type of principal, right? To specific types of identities based, for example, on a tag that they have on them. So I can do that using what is called the resource-based policy. I can go to the resource and then use that policy in order to limit what certain principals, or all principals even, can actually do on it if I want. So this is the first mechanism. Now, the second mechanism is what is called a permission boundary. So permission boundary is a policy that I can put on an identity, and that would actually limit what that identity can potentially do. It's very simple to put. All I do is I go to the identity. There's a section for permission boundary, and I can set it. I can choose. It's also a document, right? So it lists permissions. So in this case, what this permission boundary would do is it will allow everything other than actions on a specific bucket. As you can see here, they're denied. And as you can, again, see from this diagram, it's not, the permission boundary is not actually going to allow anything. It would just limit anything that is outside of the permission boundary, because the permissions are actually granted from the identity policy. Now, a permission boundary is great, but it's only effective for one specific identity. What we can do if we want to use something more general is we can perform what is called a service control policy. Now, if you remember from before, I had this tool called AWS Organizations, which allows me to manage accounts. Now, the way this would work is if I want to basically put what is essentially a permission boundary for all identities within an account, is I would set a service control policy on an account, and that would basically function as a permission boundary on all identities within that account. So it works in a very, very similar way. I just do it from AWS Organization because I manage it for all identities. Now, these are sort of the main mechanisms in AWS in order to limit the access. In Azure, we have two mechanisms that are important to know. One of them is locks. So I can go to scope and set a lock on it. Now, in Azure, it's much, much more straightforward, right? I can go to here, for example, I'm in a storage account. I set a lock, and that lock is either read only or delete. So it would basically limit identities, all identities, from either performing modifications on it, that is the read-only lock, or deleting it. And I can set I can set the lock. That's it. It's just that simple. In AWS, of course, the tools that we use, the denies, and they're policies themselves. So they're much more flexible, but they're also much more complicated to use. Now, another mechanism that we have in Azure is what is called the deny assignment. So, and again, the deny assignment is not very available for me to create in a custom way. So basically, there's very limited ways in which I can create one. So one of them is, for example, using what is called a blueprint. So I can provision resources in Azure using a blueprint, which is basically a recipe for creating resources. So I set up a blueprint, and then I assign it. And when I assign it, basically give the command to create the resource, I can put a lock on it. And that lock it's not the lock that we saw before. It's the lock assignment. What it means, it would set what is called a deny assignment that would either make the resources provisioned using that blueprint, it would make them either read-only or it would limit the delete function on them. So this is, and this is, again, this is how it uses it. This is what the denied permission would actually look like. Now, the main takeaway here is that AWS has very, very flexible mechanisms for applying restrictions, right? What we saw, the service control policies, the permission boundaries, the denies, they're very, very flexible. You can do a lot of very, very interesting things with them. But again, they require you to actually understand what the policy structure looks like and how to use it. And in Azure, it's extremely straightforward. However, it's extremely limited, right? I can't do it in a very, very granular way, but it is very, very similar because I can't do it, for example, on an action level. I'm very limited in how I can do it, but it's very simple to apply. Now, what we're going to go over next is we're going to go over some native governance tools, some basic examples of native governance tools that we have for the environments. So in AWS, I think one of the main governance tools that we have is what is called Access Analyzer. It has very, very important functions, and we're going to go over the importance of them. So Access Analyzer basically analyzes access, and it gives you some very important functions into understanding the access that you have to resources. Now, as we mentioned before, a resource-based policy is a very good tool that allows external access. Now, external access is something very sensitive, right? You allow access to identities outside of your account. So what Access Analyzer allows you to do by creating what is called an analyzer is basically create an alert for someone giving access to a resource to anyone outside of your account. Now, you can actually do a very nice configuration that would make it streamline into CloudWatch, and then you can monitor it, right? This is what it would look like. And it's a very, very good tool. Now, it also allows you to make this monitoring done when you are about to give the access, right? So what we saw before, we saw this was creating an alert when the access was already granted. Now, very recently, they put out a feature called Preview that actually shows you when you're about to set a resource-based policy. It would let you know if, when setting that resource-based policy, you're actually going to grant more external access to identities outside of your account, right? This is very important because when you're about to do it, it's going to show it to you. Now, another very recent and also very important feature in Access Analyzer is that it can actually take logs and your configurations and make analysis for them, and then understand how to generate a least privilege access policy. So the way this would work is for the identity, you can see this generate policy function. You choose how long you want to look at logs, and then it looks at the logs. It looks what the policy actually needs. It walks you through this wizard, and then it actually suggests a policy that you can use for that specific identity. Right? It's a very nice feature, very, very recent. Now, another interesting tool that you can use is what is called Access Advisor. This is much, much more straightforward. So Access Advisor is a tab that you basically have for your identities in AWS. And what it shows you is it shows you for each service that the identity has access to, what was the last time it was actually used. So for example, here we can see all these services used today, but here, for example, we can see that we have several services granted from this policy that were last accessed 21 or 27 or 47 days ago, right? Now, this is done on the service level for most services, but for some services, it can actually be done on the action level. So it's much more granular. So for example, for EC2 or IAM or Lambda or S3, these are the services. It can actually be done on the action level, So we can see when was the last time the identity actually used each action. Now, sorry, don't have time for that. Now, these are nice tools in AWS. Now, in Azure, there are, again, two nice tools that I want to talk about. One is Access Review. So Access Review is a nice tool that helps you basically create a mechanism in your organization to make people review the access that they have or other people have. So it's either their subordinates, or if it's maybe an analyst on your security team that can look at current access that identities have. So basically what you do is you set up a process for it, right? So how this would work is I would create a new access review, and I would choose what is to be reviewed. So for example, I can review membership in a group. So I choose the group, for example, and I choose how long or how frequent it's supposed to be done. And then I also choose who's going to do it, right? It can be either the group owner or someone specific or the manager of the users. And then what they do is for each cycle, they can basically review who is the member of the group in this case, and choose whether or not they still need to be in the group, right? So it's sort of a manual process, but it's very, very effective. I think it's recommended that it would be manual, so access is not just taken away willy-nilly, but it can be very effective because you put your organization into a mechanism or into a rut that would make them review periodically the access to several permissions which are sensitive. Now, another tool which is very interesting is Azure's privileged identity management. So Azure's privileged identity management allows you to provide access to sensitive resources and to sensitive actions, and to do it on eligibility basis and not necessarily on active basis. So the assignment that you will make will mean that the identity that gets the access does not necessarily have access all the time, but it can actually request for the access to be enabled, and then it's just given on a just-in-time basis. That's one thing that you can do, right? The other thing that you can do is that when you grant the access, you can also limit the assignment to be for a specific time window, right? So here we say that we give, for example, an eligibility, not active assignment, and that there's a time frame for that assignment, right? So, for example, we can configure the role that we're going to assign, and the role that we're going to assign basically going to be activated for 8 hours whenever it's activated. So if a user wants to actually use the access, it needs to request access, right? It activates it, it requests access to actually use it, and then someone actually needs to approve it. And it's only active for a time frame of 8 hours. And we can also limit that specific frame for how long that assignment is actually valid. So these are two very, very nice tools. But one thing I want to leave you with is, and again, this is just the foundation. Of course, there's a lot of content to talk about here, and this is just like the very, very basics. And I hope that you got a nice introduction into how you can actually go and then explore deeper. But one thing I want to leave you with is the case for doing this kind of analysis in an automated way, right? So the tools that we talked about, and there are also other tools that you can use. For example, in AWS, there's Policy Simulator that we don't really have the time to talk about, but it's also a very, very interesting tool that allows you to ask the question of, does one identity actually has the ability to perform a function on a resource? Now, that tool and the tools that we saw are great for specific queries. So if you want to actually do some kind of analysis and you want to look at a specific identity, for example, that want to do specific things, or if you want to, for example, set review, like in Azure, for a specific group, that those tools can actually be great for it. But the real problem that we have, even when we use native tools, is doing it at scale, right? If we want to achieve least privilege, that is making sure that only the proper permissions are granted to the proper users that actually need them, then this mission is actually very, very, very difficult if we want to do it at scale. Because we need to do it at scale. We need to do it for all the identities and all the resources all the time. And that is very, very difficult, even if we use those native tools. Now, another thing is we also need to have it done automatically. We need to do it all the time because things change and things are very, very dynamic. New resources pop up all the time and new identities and various configurations, etc. Now, another thing that we need from a security, from information security perspective, is we need these information to be contextual. Because I think one of the most important things in cybersecurity is prioritization. And if we know of excessive permissions in one place and in hundreds of other places, then we will need to prioritize that. That means that we want to find the excessive permissions on the identities which are most likely to be compromised. And we need to basically fuse the information about permissions with other information, such as information about security posture. And finally, we need to have this kind of information done in a very, very, very granular way. So just a few examples of what we saw before is, for example, we talked about Access Advisor, right? Then an Access Advisor does have, it is a very, very nice tool. But if we talk about granularity, for example, then as we can see, Access Advisor only really allows us to have action level insights for four services, right? For EC2 or IAM, Lambda, and S3. Now, granted, they're important services, but there are other services such as, for example, KMS or DynamoDB or RDS, where that kind of functionality does not work. And on top of that, Access Advisor does not work even for those services on the resource level. So, for example, if I have an identity that can use, let's say, for example, even S3 functions on all my buckets, right? All the storage in my account, but it only really uses it for 2 resources, then even if I have action level analysis and I know what actions it used, I still don't get analysis for what resources it used, right? So this kind of granularity is important because if I want to limit what the identity can do, I want to limit it to the resources where it actually uses them. And for example, Access Analyzer, which is also an amazing tool for generating these policies, it just does it it does it for one identity at a time. And it's also kind of limited in how much it can digest, right? And it's also limited in how many I can generate every day. Here you can see a snippet from the documentation. So what I'm saying for is that if I want to do it in scale and I want to do it very granularly, I need a dedicated framework or a dedicated platform for that. And this is exactly what we do. This is where we came from. And we created a multi-cloud platform that can actually do it for example, for Azure and AWS at the same time. So what we have is we have a SaaS solution that integrates with your environment. It basically does this automated analysis all the time of your configurations and permissions. It streamlines the information into one identity intelligence dashboard. So for example, if we have a machine that can assume a role in AWS, you will see it in one place as a machine that can use a managed identity in Azure, right? So you can see it all in one place. You don't have to, mess around with the console in order to figure out who can access what. And of course, it does it at scale. Now, you also see other information about the identity. So for example, you can see whether we have identities which are third parties or are exposed to the internet, or for example, they have access keys enabled, which we discussed as a very, very risky. And another thing that we can do, of course, is we can filter by all this information. So for example, I find machines that are public to the internet. I can also very easily look at configurations which are otherwise very hard to understand, such as network configurations, and also visualize the permission sets that I have. So for example, here I can see the permissions that these machines have using their role in AWS. And I can see which ones of them are excessive, because we don't only analyze the configurations, we also analyze the logs, and then we see what is actually excessive. You can also get it in a list view. And then finally, you can generate a policy that will replace the existing policy, which is excessive. So for example, let's say I have a policy that is very excessive, and as we mentioned, can happen very easily just using this wildcard. And I can replace it with a policy that only allows specific actions to be performed on the specific resources. Now, we also, of course, fuse this information with information about compliance standards and about security posture. And we basically give you one dashboard you can use in order to mitigate these kinds of excessive permissions and security posture in order to gain least privilege and really minimize both the attack surface in your environment and the blast radius from various attacks. So this was a lot to take in, a lot in one session, and also a little plug for what we do. So if you have any more questions, you can send them. I don't know if there were any questions on the chat. But either way, if there are, I'd love to take them right now, or you can send it to us. I believe my information is on the invite, or you can contact us if you want to see a bit more of what our product can do in your environment. We would love to set up a POC if you want to really understand the permission sets in your environment and where they're excessive, fused with your security posture. So that was our presentation. Hope you enjoyed it.